I'm Mr. McBrien, and this is just a quick video to give the answers to the example questions from yesterday's slides. So as we know, the curriculum would like us to be able to talk about electron configurations, and that's what we'll do today. The practice questions that we were given were simply to identify and describe the outermost electrons for these elements. Pretty straightforward stuff. In terms of a step-by-step approach, first off, you want to use your periodic table to determine the number of electrons. And of course, that's just simply your atomic number. Once you have that number of electrons, you're going to use the 4 rules that we covered in the previous video to add the electrons in order to the system. And the key is to identify the last electron that you add. And that's the one that you're going to describe its quantum numbers. So if you're not sure how to determine that electron configuration, then you'll want to go back and review the previous slides that talked about how to add electrons systematically to an element. Go ahead and review that, and then you can do the rest of the question. So we're going to take that electron configuration as a given as we go through these examples. So the first one we want to work on is potassium, and its electron configuration according to the filling rules would be this. Now this is just associated with 14, 15, 19 electrons. So knowing that it has 19 electrons, we fill them in order according to the 4 rules, and we get this result. And from there, the key is to realize that the last electron that you put in was this one. Now we want to determine the 4 quantum numbers that uniquely identify this electron. So first off, n equals 4, so the principal quantum number is 4 for the outermost electron. No big deal. Next, the s orbital, by definition, has L equals 0. And as soon as we know that L equals 0, there's only one option for m subscript L. There is only one 4s orbital, and so its number for m subscript L will be 0, the only 4s orbital. And then we usually take the spin as up or plus a half. And so those are the 4 descriptors for this outermost electron. And so our answer to the question then would be 4, 0, 0 plus a half. All right, let's do chlorine. Now chlorine, you should go and determine its atomic number again, which will give you the number of electrons. Number of electrons by my count was 17, I believe. 10, 17, yes. And then we have to go ahead and fill the orbitals according to the 4 rules, which should give us something like this. Now with this in place, we can see that the last electron filled, now here's the trick. Okay, don't make the mistake of thinking this was the last electron that went in. In fact, the last electron that went in, according to Hund's rule, is this electron here. So this is the one we're going to give the 4 quantum numbers for. So n again equals 3 for the energy level, the principal quantum number. And the p orbital, by definition, has L equals 1. Now here comes the trick. There are 3 different p orbitals, x, y, and z. So we have to identify which one. And they're identified by m subscript L, which can run from -1 through each integer to +1. So since this is the second one, m subscript L will equal 0. Finally, we have our spin. Now, because this is a paired electron, we usually describe it with a spin of -0.5. So I encourage you to do that as well. When it's a paired electron, you choose -0.5 as the spin. So our quantum numbers then, 3, for the energy level. 1 describes the p orbital. It's the second p orbital, and its spin is down. Okay, titanium. We consult the periodic table, find out that there are, let's do the math, 10, 18, 22 protons, which means there will be 22 electrons since it's uncharged. And the last orbital filled, well, that'll be this electron right here. So our challenge becomes coming up with the 4 quantum numbers for this electron. Well, the easy one, the energy level, the principal quantum number is 3. Now, since it's the d orbital, that means that L equals 2. And here comes the bit of a trick. The m subscript L will be from -2 up to +2. So it's not -2, it's -1. And finally, it's an unpaired electron. It's the first one to go into there, so we'll give it +0.5. So our answer then, 3, 2, -1, +0.5. Okay, our last example. I'm not even going to count the electrons because I'm too lazy. Here's our electron configuration. Here's what our f orbital looks like. And our challenge becomes to identify this electron here, the last one to get filled. So, principal quantum number 5. Because it's an f orbital, L is equal to 3 by definition. Because it's in the last spot, we go from -3, -2, -1, 0, 1, 2, 3. M subscript L should be +3 for that 14th electron. And because it's the last one in the pair, we can give it a spin of -0.5. So, our quantum numbers are 5, 3, +3, -0.5. Okay, so I hope that was helpful. When you're asked to determine the quantum numbers for the outermost electron, figure out, whatever way you need to, which electron was the last one to enter the configuration. Start with your periodic table, find out how many protons there are. Use the 4 rules to figure out which one was the last electron to put in. That's the one you're going to describe. Determine the quantum numbers from the location of that last electron. It's really very straightforward once you get used to it. The spin's arbitrary, but do everyone a favor. Choose +0.5 for the first electron to go into an orbital and -0.5 for any paired electrons for the second one to go into an orbital. For your homework, please go ahead and read over the note and do the worksheet. If you need extra help on this stuff, there's some good references on this page. Lots of assistance out there to help you with learning the 4 quantum numbers. Thanks very much, and have a great night.